But this will be later. Okay, thank you. See, this is high tech. For the small things, I have this document camera.
Everybody can hear you when you have them.
I know. It's okay.
Okay. Come closer, ladies.
Hi, ladies.
Come closer.
Hi.
Ladies only?
Women in Europe. Okay. Do you know each other? Maybe. You know? Mhm. Yeah. Yeah.
But it's still 1 more minute.
Rhea.
Ladies
Like
and
this.
gentlemen, 1 more minute. So 21. Okay, 1 more minute. That's fine. So I start, huh? Yeah. Hello, everybody from Vienna, and welcome to our Hybrid Win for Peace webinar from the Vienna International Center, supported by the IAEA. So as a former WIN IAEA president and IAEA Nuclear Safeguards Inspector, it's a special pleasure for me to be here because today we are going to speak about what's new in terms of safeguards verification equipment. So first of all, I would like to welcome you all to this hybrid seminar. We have a few ladies here in the room from the IAEA and a special guest who came all the way from Egypt, Marwa, our Win for Peace member from Egypt, who made this journey just to see the equipment here. So welcome. Before I start off, I would like to hand over to Amal Al-Refai, who's the WIN Global Vice President, to say a few words of welcome.
Thank you, Eva, and ladies, we hope we say after 1 minute, gentlemen and gentlemen. Good afternoon. It is my distinct honor and privilege to welcome you all to this significant event organized by Women in Peace, a group of expertise. Today, we gather to explore and discuss the innovative safeguard equipment developed by the IAEA, which marks a pivotal advancement in our collective efforts to ensure nuclear safety and security. As a Vice President of WIN Global, I am immensely proud to see such a diverse and dedicated assembly of professionals who are committed to promoting peace and security through the responsible use of nuclear science and technology. The novel safeguard equipment we will delve into today not only enhance our ability to monitor and protect nuclear materials, but also exemplifies the critical role that women play in driving technological innovation and global security. This event is a testament to the power of collaboration and the importance of inclusivity in our field. By bringing together experts from various backgrounds and disciplines, we are fostering an environment where ideas can flourish and solutions can be found. The IAEA's new safeguard equipment represent a leap forward in our ability to detect and prevent the misuse of nuclear material, thereby contributing to safer and more secure world. I would like to take this opportunity to acknowledge the remarkable efforts of women in peace group of expertise. Thank you, Eva, for all of your efforts and for organizing this event. Your dedication to advancing the role of women in nuclear science and promoting peace is truly inspiring. I'm confident that the discussions and collaboration that will emerge from today's event will pave the way for further advancements in nuclear safeguard security. In closing, I encourage each of you to actively participate in the session, share your insights, and engage with your peers. Together, we can continue to make significant strides in safeguarding our world, empowering women in nuclear affairs. Thank you.
Thank you very much, Amal, for your kind words of introduction. I would also, before I forget, welcome the WIN IAEA president, who is also present here, Ms. Janet Donner. And let's now go in medias res and introduce Ms. Ektimal Al-Nimri. So Ektimal is the leader of a group in the Department of Safeguards in the Technical Division that is responsible for the development, deployment, and advancement of instruments that are used by inspectors in safeguards verification. And she has extensive experience and state-of-the-art and knowledge of emerging technologies that are used to enhance IAEA inspector activities, verification activities in the field. Before joining the IAEA, Ektimal worked for the CTBTO, which is also located in the Vienna International Center. There, she led technical evaluations and performance assessments of nuclear radiation acquisition systems and data analysis tools, contributing to the continuous improvement of the CTBTO verification regime. At the national level, Ektimal served as the head of the Radiation Measurements and Analysis section of the Jordanian Nuclear Regulatory Commission, and she was instrumental in establishing and expanding the section, integrating various nuclear technologies to support a wide range of verification activities. Ms. Al-Nimri holds an advanced degree in nuclear physics and nuclear engineering, and she has received multiple awards for her performance and achievements at both the national and the international level. Before I hand over to Ektimal, please keep your questions to the Q&A at the end of the presentation, and you will not only have the opportunity to listen to Ektimal, but to actually see some equipment close by, because she has a separate special camera to do so. So Ektimal, the floor is yours.
Thank you so much, Eva. Thank you so much, everyone. Amal, organizing this. Do you hear me? Thank you for organizing this, and it's my pleasure to present today our novel development for equipment supporting safeguard activities. Before starting into the presentation, it's always challenging for me to explain to people who doesn't work with me, working in the field, going on inspection, dealing with the equipment, what we are doing. So this is always has been the issue when I explain this to my family, my sisters, but it was even more challenging when I tried to explain this to my daughter when she was 7 years old. And she was telling me, Mommy, what you're doing, what you're doing. And she's excited, she wanted to know, but it was very difficult to explain. So I used a very simple way of explaining this. Knowing she watched some movies, I told her, did you watch Mission Impossible series? She told me, yes. So what Tom Cruise is doing? Oh, he's trying to prevent the bad people from having the nuclear weapon. I said, okay, exactly. We're doing even more than Tom Cruise. We are trying to put some measures and systems in place so people can't develop this nuclear weapon. And this was the best I could say and explain to my daughter. And now I would like to walk you through what we do in our division in Safeguard in LGTS and in the Department of Safeguard contribute to this. Before I go into the topic, the main topic, which is the new development in instruments, I want to explain what we do in Safeguard. What is Safeguard? What equipments used in Safeguard? What are the new equipment that were developed in order to address certain challenges and gaps to help inspectors perform the verification in the field? So what is Safeguard? Safeguard is a set of technical measures that enable the IAEA from independently verify whether the states are honoring their obligations. And to do so, we have brilliant, smart staff. They can be inspectors, they can be analysts or technology experts. And they perform activities either in the headquarters or in the field. When we talk about activities in the field, they need equipment. Why they need equipment? Because the nuclear material that the operator use to do like nuclear, use it in the nuclear power plants or research reactors, they emit radiation. The radiation you can't hear, you can't touch, you can't have any clue with your senses. So you need equipment in order to measure the activities, in order to measure what type of nuclear material they have and how a quantity of they have. Therefore, the Department of Technical and Scientific Services provide two main types of equipment. The first one is to verify the nuclear material against the operator declaration. And after the inspector is doing the verification, they leave the facility. And when they leave the facility, they still need to make sure that the operators did not have access to the nuclear material, did not change what was verified. That's why we need the other type of equipment, which is to have them maintain the continuity of knowledge. I will start by talking about non-destructive assay. What do we mean by non-destructive assay? Anyone have an idea what do you mean by non-destructive assay? And it's not my team. To verify the nuclear material, we need to measure. And you either have the sample, destroy the sample, and measure what type of nuclear material, or if you have a fuel assembly, you don't want really, after all the work the operator and the manufacturer did to produce the fuel assembly, to destroy the fuel assembly. So you need something that you can measure without destroying the nuclear material. And this is what we call non-destructive assay. And it's mainly used in Safeguard for measuring special nuclear material, mainly uranium and plutonium. You might heard about, plutonium used for developing a nuclear weapon, uranium, enriched uranium used in developing a nuclear weapon. So these are what we mention and what we concern about in Safeguard, and we call them special nuclear material. To give you an idea, we have over 200 Safeguard inspectors use NDA systems on a daily basis. The team I'm leading are working very hard to provide this number of instruments. So inspectors in the field, they always have access to the instruments they need to measure and verify the nuclear material. And we have over 5,000 pieces of non-destructive assay. So a huge pool of instruments. Mainly they base on a technology which are gamma spectroscopy, neutron counting, and the shrink-wave viewing devices. Anyone is familiar with the shrink-wave viewing devices? So the cool thing about shrink-wave, and it's really cool, it's produced when the electron travels faster than light. And we know Einstein told us that light is like the most speedy, and no one can exceed the speed of light. But this is true in vacuum. In water, however, the electrons can travel faster than light, and therefore nuclear material in the water will produce a shrink of radiation. And we use this phenomena to verify whether the fuel assembly stored in wet storage are really a fuel assembly, not dummies that have no radiation. The flow of the non-destructive systems is over 1,000 per year coming and going to the field. Some equipments are stayed in the field, some they brought back, and this is a continuous effort to make sure that all instruments are working and helping the inspector to verify. So what challenges we have? We have our instruments, we have different variety of instruments. Nonetheless, these instruments, with the current development in nuclear industry, are not enough to verify all types of nuclear material. Operators in nuclear industry are becoming more and more advanced, and we have to be ahead of the game, seek different technologies, cooperate with different partners, and see what we can do to address the new challenges. For example, we have the nuclear material you can see here. This is a fuel assembly. And in the fuel assembly, we have pins. Depending on the type of the fuel assembly, we have different number of pins inside the fuel assembly. And to verify the integrity of the fuel assembly on the pin level require a very advanced technology that I will talk about later. Also, we have the new fuel assemblies. They have burnable boson, and these burnable bosons, they absorb the thermal neutron. And this is not a bad thing, actually. It's good to have these thermal boson to absorb the thermal neutron because this controls the chain reaction. We don't want to have a nuclear explosion. So it's good to have them as a safety feature, but it's bad for us because we need to come up with a technology that is able to measure with a high accuracy, although the new fuel assemblies contain this percentage of burnable boson. So this is another challenge that we had addressed. As you might know, not everyone is interested to go on the bridge, have equipment, and verify whether the spent fuel pond contains fuel assemblies. It's mainly safeguard. Therefore, it's not really out-of-the-shelf commercial equipment that you can go and buy. It's become obsolete sometimes, so we need to find a solution, we need to find vendors, and we need to improve our way of verification and make inspector even more happy with what they have. Another thing, like the number of nuclear facilities are increasing all over the world. Nuclear industry become more and more popular. People interested, even countries were not considering using nuclear power, became interested. And this increased the number of the work. However, at the safeguard, we are not really professionally increasing the number of inspectors. We have more work, and we need to address this need, this huge demand. And therefore, we need to improve productivity and come up with something that can do more work with less. In addition, we have, as I mentioned, we have like 5,000 pieces of equipment, NDA equipment only. And you can imagine there are different softwares used in different type of instruments. And we want to standardize. We want to reduce the number. We want to reduce the type of instruments. And we want to standardize the software used. And this is also another effort that were done to make inspectors more familiar with what they use, less training is needed, and easier for them to train on one instrument, one software, and do the work. So let's talk now about verification of low-enriched uranium fresh fuel assemblies. I don't know how many of you is aware of the nuclear fuel cycle. So nuclear fuel cycle is a very lengthy topic. I will not go there, but I wanted to say that to start any process, to use a nuclear material, you need to prepare to extract the uranium, for example, then do it in a certain format that can be used in a nuclear power reactor or research reactor. And the first item which can be used in a nuclear power plant is the fuel assembly. A fresh fuel assembly, not irradiated. And we need to find equipments and find measures to verify all the nuclear material over the path of the nuclear fuel cycle. And one of the challenges is, as I mentioned, having a fuel assemblies with permeable boson. And the new industry is having more and more of this fuel assemblies. And we did not have the instruments that is able to do this measurement without need to have correction. However, how we address this? We came into state-of-the-art technology using liquid scintillators and developed an equipment called fast neutron caller, which can measure the nuclear material based on the fast neutrons. We don't care about thermal neutrons anymore. We can have burnable boson in the fission fuel assembly. It's okay, because we use fast neutron. Not only we change the way we detect, but also we improve the electronics. It's faster now. We introduce Monte Carlo simulation. We have code MCNP, which is used to simulate different geometries and come up with the solution and with the value of the nuclear material without much effort and much corrections needed. Also, we made the software easy for inspectors to use. So easy for the inspector, faster, and overcome many challenges. The benefit over the old system, as I mentioned, we don't do any corrections for burnable bosons, and it's easier to use, and we don't need to do corrections. This is what we call PJET. And you can see there is a video animation. It's based on passive gamma emission tomography. Anyone heard about gamma tomography? Do you know any uses of gamma tomography outside of Safeguard? Okay, well, here's the thing. Before joining Safeguard, before coming to Vienna, before like 20 years ago, I worked in a hospital which they use the gamma camera. And what they do, they inject patient with technetium or radiopharmaceutical, and they put them in an instrument where it makes an image and make the diagnosis for the patient based on nuclear camera. So gamma camera is used in medical and industrial. And this is what I find it cool here, that we don't limit ourselves to what we know. It's not only gamma spectroscopy, it's not only neutron. We go beyond and further, and we see what other industries are doing, what other applications, and we try to apply them here in Safeguard. And as mentioned, as you can see here, we have two bags. So this side contains 80 CZT detectors. So one side contains 80 CZT detectors. And the other side also contains ATCZ detectors, the amount of effort and time used to calibrate this instrument is enormous. And then it's sent in the field. It's merged inside. Here you can see the other picture. It is inside the water. And then the fuel assembly is inserted in the instrument. And the instrument is rotating, making a 360 image. And the image, as you can see here, is different from, like, it shows the pin level of each fuel assemblies. So if any pin is missing, we can verify that. And why this is important? Because the amount of nuclear material that can be diverted, that can be taken on that scale is really significant. And if operators or people outside, they don't know that at the agency we have this capability, of course, they will feel free to do so. So having this technology, having this capability introduced is really a breakthrough in our safeguard verification techniques. Then we have this cool instrument here. It's called XCVD. This is the shrink-off viewing devices. Previously, inspectors used to, as you can see here, stand on the bridge, having this like telescope thing going and looking downward on the bridge. And it was all subjective. Like an inspector can see something, can say, I see a fuel assembly, but nobody else is seeing that. It's only the inspector. The image is not recorded. If the inspector go out of the spent fuel, have no record, no evidence that what the inspector saw was a fuel assembly. Eva, here, you did that before, and
Well, you have a pool map, so you go by the pool map.
Yes.
So, but,
it was a challenging
yeah,
thing,
yeah,
right?
it was, yeah.
Very challenging, because Eva also was an inspector, I was an inspector, so we understand the challenge there. And this is really a breakthrough. Something I did not mention, that what we used for this new technology for shrink-off viewing devices is taken from astronomy. So astronauts, they develop their science. So this is what I'm saying, that we go not only for our industry, we go and see other industries, astronomy, medical applications, and in some places, security. Once there was a workshop to see how industry provided something which can seal and secure the transfer of diamonds. So we look everywhere. We have this technology sourcing, and we look into all possibilities. We make workshops and then come up with solutions. We talk to operations, to inspectors, and see what is the best. And then we have a partnership with other industry to develop and procure what we need. A simple comparison between what we have now, here, I can have it here. So this is the new XCVD. You can see this is the part with the lens that goes down and see that spent fuel. And here there's a display. And in the display, you can see exactly this image here. The video, what we show in the video. And
Sorry, can you hear me? We have some problems with the audio. We can't hear.
Sharing. I will share again. And let's see. Technology. This was an issue. This was a huge issue to
Sorry, Eva, can you hear me? Maybe you can change the microphone.
Other side, you think? Look out and look in the sheets from there. You can write to her because she doesn't hear you. Yeah. You can. No. show you cool things now. This is the new.
Is it better now?
Yes,
Can you
perfect.
just, it's better now?
Yes, perfect.
Okay, thank
good,
you.
good.
Okay. So next slide, I think.
Yes, next slide. And this is the coolest thing we have. This is the robot. We managed to produce a robot. We managed to have an instrument that can move automatically with a program and do the verification. As you can see in the video, it's moving row by row and recording images. The main technology is the same, like the body here, this body here is the same as this one. So the same lenses, the same technology put into the submerging platform so it can float in the water and record while it's moving. We can think of
I think you see because they are seeing my image now. Oh,
Mm.
wait a sec. Move closer here. Move closer here.
Mhm.
All right. Fantastic.
Okay. And you can see that it's moving without the need for the bridge. The main challenge, for example, for inspectors, that they need to be on the bridge, as we saw in the previous picture, and the operator has to move the bridge back and forth to do the measurements. Now, operators are so happy, inspectors are very happy, especially, for example, in some countries and some facilities where the radiation is really high. This is very important. We save the inspector from not only the workload, but the high radiation. And it's way more productive. The mission, the campaign that used to have 3 weeks, now it's done in 1 week. Saving money, supporting inspectors, and save them from high radiation. Finished from the talk about spent fuel and the shrink of light devices, talking about the breakthrough in gamma spectroscopy, gamma spectrometry. As you can see on the picture here, we were talking that we have many instruments, and here we're talking about four types of instruments that are replaced with one instrument. This cool instruments, and I don't know if you can see it, or shall I use this one? Shall I use this? Because I have another camera. So this, you see here, we have 4 crystals that also based on the gamma tomography. And this piece of instruments can be used in different platforms that I will explain later. We have different accessories. Yeah. So different accessories. Here, this is one that we can insert this here. And this is a magnet. As you can see in the picture, this is, for example, a UF6 cylinder. It can attach to the UF6 cylinder and leave it to continue making measurements. So inspectors don't need to hold it or have a platform like we see here to put the instrument, the big one, but they can attach it like this. It's 0.5 kilo, and it's replacing many instruments, which like can be 2 kilograms or needs liquid nitrogen. It saves a lot of time, and the resolution, the efficiency is comparable to all these instruments. reduced the number of instruments, and it's used the software, which is MCAD, which is the standard instrument, the standard software. And for this, we can have a fully integrated system and standardized and easy to use by inspectors. I can show you more about this later on, but let's move on and
They don't see this camera. I think you need to switch, right? They don't see it in the display. This is all they don't. You have to stop sharing the presentation if you want to display the camera, I think.
Okay, then maybe we do it later.
Okay, maybe in one go you just show them.
Yes.
It's
But this
okay.
camera, they can use, they can see this camera.
Yes, well, yes. This one, here.
This one here.
This is the classic.
Okay, this they can see. Okay, so for this one, this is also the same model. So it's the same as we used here, but it's in a different platform, and it will be used replacing the HM5, the famous HM5, and it contains several icons, which covers all the functionality of HM5. The technician of HM5 is here in the room, so this will be your new instrument later on. And it looks so cool because people will think, okay, this is like a Star Wars thing. And this is what I show. So this is, for example, an option to measure the rod. This is not really an actual rod. This is a normal rod without radiation, but in the facilities, we can really measure the rods. We can measure the bullets. Here, for example, you can see this is the accessory where you can put the bullets inside and do the measurements for different type of nuclear material in different format. So it can be bulky like this. It can be like the rods or the bullets in which all of them, like the rods and the bullets, from fuel fabrication facilities. So it covers fresh fuel fabrication, and different types of facilities. What we presented okay. Why it's turned like and what we presented so far was when inspector have the instruments and they take the instruments with them, they do the measurement, and it's called attended. However, inspectors have family, right? They have to go back to see their family. They have to sleep. We can't really let them do all the job. We need to have another alternative, which is a system that can measure without the presence of inspectors. And this is what we call unattended monitoring systems. So similar equipments that we use for attended mode, but now it's developed to be used in unattended mode, doing continuous measurements and transmitting data to the headquarters where inspectors can have access and they can analyze. It's measured not only nuclear material, but also can measure pressure and temperature. For example, a research reactor, you want to verify whether the operator was operating the research reactor for 80 days. And for this, you will need to measure the flow, you need to measure the temperature continuously, and this is what can be done also with an attended monitoring system. We have also developed a new unattended mode for fork detector, portable, easy to use. This is the fork detector. As you can see, it's called fork for a reason. It looks like fork. And it contains both gamma and neutron. This is the fuel assembly. And the fork detector, we put the fuel assembly inside the fork detector to measure the quantity of nuclear material using gamma and neutron together and compare it to the operator declaration. I used this device in Ukraine last year in October, and it was really a lifesaver. During transfer campaign, inspectors are on call. Operator want to move the fuel from from the wet storage and put it in a cask and move it later on to the dry storage. And they do this campaign over like 3 weeks. They do it overnight. They do it continuously. And I can't imagine an inspector would like to stay there observing everything, verifying everything for 3 weeks, day and night. And this is why this type of instruments are crucial. It's developed to an inspector go there, verify that the data is taken correctly, the system is working, data is stored, and then they go. After the transfer of the fuel assemblies moved from the wet storage to the cask, they can later on verify that everything was measured, and that's it. Reduce a lot of time and make verification possible.
I think some participants are still struggling with the audio, so I've put off and on the microphone. Let's see. I hope that works now.
And we remember, what is this, PJET? Do you remember? Yeah, it's this. We talked about it. This is the attended mode. And when it's unattended, it's called UJET. So it's the same, it's exact same thing, but attended, non-attended. And for the unattended, we have, of course, the electronics, the data acquisition, and all these things installed in the facility, because this instrument will stay there in the facility and do the continuous measurement and verify whether there is any change in the pen level for the nuclear, for the fuel assembly. And here we can see how it's like the calibration and how the setup is done to do the calibration for the CDT detectors. Later on, I will talk about the NDA instruments and I will show more applications. However, before we move into this session, I want to continue talking about other equipments which is used not only to verify the nuclear material, but now to make sure that after inspectors verify the nuclear material was not touched or moved or changed. If anyone will try to temper the nuclear material, use it, open it, we have equipment in place to prevent this. First thing is seals. And for seals, we have both passive and active. And what do we mean by passive seal? Passive seal are the seal that, for example, this. I'll try to make it. Yes, we can't. Okay, we can't, but then I can show it to the room. Yeah. So something like this. This is passive. No, nothing, it's not electronics, nothing connected. You just have to have the inspector go in the field, verify, bring it back here, verify, that's it. Other types of seals are active seals, like this one. We have different types of seals, active seals. There is the EOS, there is the active universal system seal. The common thing is that they can be connected to remote monitoring. They're electrical. They connect to the computer. And then if someone tried to open, it's recorded. Every time anyone open, it's recorded. Nobody can temper or touch any nuclear material, open the seal without us knowing that it was opened. And there is a very systematic and very accurate system to record who opened the seal, when was the last time the seal was opened, and then compare it to previous inspection. Okay, was this consistent with the previous inspection, or someone in between tried to open or tamper with the nuclear material? Other systems are the surveillance. Of course, we can do human surveillance. We can have inspector stay there, watch the reactor, the reactor hull or the cask, and travel with the operator when they transfer the cask to the final repository. But I don't think it's a very effective or efficient way of doing safeguard. That's why we will need not human surveillance, real surveillance with cameras. But most important that we have authentication, we have public key infrastructure, we have a certificate, digital certificates to make sure that the information recorded by the camera is authentic and it's correct and not tampered with. And this is why we need the new, I will later on show you the cameras and I show you how it looks like. But let's finish this now. We need this state-of-the-art cameras with high security and to help inspectors reviewing the surveillance, because the surveillance can be 3 weeks or 1 month. We need to make sure that we have state-of-the-art technology to help inspectors, and we're using artificial intelligence to post-process the images and to identify objects. So if there is any movement, the software will tell the inspectors, okay, this is a region of interest, verify or look more deep into that period of time, instead of going through all the things. And also it can identify black seeds and other type of gaps in the surveillance. So if there is no question, I can conclude. The latest development in the equipment supporting safeguard was done during the last 5 to 7 years. There was a huge effort from the IAEA to talk to all inspectors, operation divisions, customers, and contact all the vendors, all technology labs, international labs, to see what is the state of the art. We need to stay ahead of the game. If the nuclear technology is moving forward, we need to also move a step ahead to be able to detect any possibility of tampering or changing and then misusing of the nuclear material. Therefore, the process of modernizing the equipment was based on identifying the needs, identifying the gaps, finding solutions, and implementing the solutions by finding vendors and working in close cooperation with the inspectors to make sure that we fulfill all their needs. And I will present more the equipment, but first, if you have any question, please feel free to ask.
Well, first of all, a big thank you to Ektimal for this really interesting presentation. I left the IAEA more than 8 years ago, so I can see that all the new developments happened after I left, and I'm really impressed with what has come online, because one of the big challenges of an inspector is, okay, you go to a nuclear facility, what equipment do you take with you? You have to be really well prepared to know what you will see there and what is the most suitable equipment. So I like this idea of having one equipment replacing 4 different equipment types. That's certainly helpful. Also the robot, I really like the spent fuel pool robot, which helps to avoid too much radiation exposure to inspectors, and that helps them in handling their work at facilities. And of course, the unattended monitor and the use of artificial intelligence, because you spend hours reviewing surveillance data. And if you have artificial intelligence telling you, okay, you don't need to review 5 hours, but just go to the main times when something happened. That's really very, very useful. So thank you very much for that, and a big applause to Ectimal. I guess our virtual participants they also are following with a big curiosity, and we already have questions for you. So let me. I think in my introduction, with all the glitches we have had, I forgot to say a warm welcome to our virtual participants. So a warm welcome to you, and thank you for following us through up till now. We have almost 30 participants, so that is really great. So we have one question from Nidhi Gopal. She's asking, how do NDA contribute to monitoring the safety and condition of nuclear reactors or storage facilities? Safety and condition.
Safety, okay. So safety is another topic. We're in safeguard. We're talking about the diversion or misuse of nuclear material. NDA also can use the safety, like can measure and contribute to the safety, but this is done by the other department, which is the nuclear safety. But I know, for example, we have dosimeters. Dosimeters also consider, or dose rates, they also consider as an NDA instruments, and they can measure whether the level of radiation is high or less. There are also remote measuring systems that can collect filters, collect radio isotopes, and then this can be measured using high purity germanium or sodium iodine, and also see if there is any release of iodine or any release of cesium or any release of any nuclear material. I know to answer this because in my previous job at my country, I was the section head for not only the labs, but also the remote radiation monitoring systems, which are completely remote, completely automated, and they can collect the data and analyze it and send alarm or alert if there is any increase in the dose or any release of radioisotopes that normally should not be released. So I hope I answered the question.
Thank you. And Nidhi also wants to know what nuclear regulations and policies govern equipment safety. So what are the measures to ensure that equipment is safe when it is deployed
Of
to
course,
the facility?
of course, absolutely, absolutely. This is a very important question, and it's part of the challenge that I did not mention here. To do this, before deployment of any new instruments, there is a lengthy process, which is called validation and authorization of the equipment. During the validation, the instrument is tested whether it's working, it's fulfilling the purpose, fit for purpose, measuring what we want to measure, accurate, correct, but also the safety. In different countries, we have different regulations. It's not only the agency regulations for safety. Different countries has different regulations. You go to Canada, they believe in their regulations, they believe in their testing, they believe in their certificates. For example, there was an instrument that we developed, we tested, we validated, we authorized, and then when we went to use it in Canada, said, no, you need to do another type of certification. So it's always different, and each country, before we deploy any instrument, we check not only our international agency regulation, but the country regulation. For example, it was a huge effort to certify and validate the robot, RCVD. The robot, because it goes into the water. Also PJET, it goes inside the water. So we had to use a very high level of certificates that can be used for submarines, sort of, but I'm exaggerating here, but because you're going down in the water, you need to measure the pressure, you need to make sure that it's under the water, there's no electric leakage will come, no explosion will come, and it's very, very important and very demanding process. I hope I answered.
Yes. So Nidhi has another question, but I suggest we go to further down and come back to Nidhi then. So Russell is asking what happens once you notice that the nuclear source is missing in the batch later after the accounting.
Yeah, of course it happens. We know that this can happen, and this is why we have follow-up action. There is always, if any doubt or if there is any change between or difference between what the operator declared and what the inspector found during the verification, there is a follow-up action. It can be either re-verifying, going and re-verifying. It can be consulting or talking to the inspector, to the operators, understanding what happened. And in some cases, anomalies are raised. You know that,
Yes.
Ivo. Yep.
Raising an anomaly in safeguards is a serious issue.
Absolutely. And we have the serious anomaly, we have the confirmed anomaly. So it's a different type, depending on what was missing and what is the difference between what the inspectors verified and what the operator declared.
Correct.
We call it operator verification difference. So,
Another question we have is, have you had a situation in which the operator or institution does not allow you to do the surveillance of a facility of nuclear material? And how do you face this situation?
Yeah, this is something that addressed on a high level. We have in our IAEA safeguard policies and CERC, we have privileges and immunities, and we have rights for the agency. When the state is signing an agreement with the agency, they agree on what type of measures they allow. Some countries, they don't allow remote monitoring. So we can't use unattended systems in a remote mode. Some, they don't allow certain type of instruments, like in some cases, they don't allow GPS, instruments with GPS or Wi-Fi. And it depends on what agreement we have with the state. It depends on the negotiation on the high level. But nonetheless, if the state has signed an agreement which allow using of a certain measure like surveillance or remote monitoring, and then they deny that, then this is something to be raised to the Board of Governors and to be followed up on.
Well, of course, the agency will always find a solution. Like, for example, if a country doesn't allow unattended monitoring, they will still have the cameras installed. And I've had that many times that I had to review the surveillance in the facility, which was very cumbersome and time intensive.
Yes.
But there is a solution to that.
But I understand the question if they don't allow the measure at all.
No, they have to.
This is the thing. This is what I say. If they agreed and they don't allow, then it's raised to the
highest level.
Yeah.
So does the country approve for inspections to their facilities?
Yeah, this is the designation. This is the designation. This is also part of the agreement that the country sign on when they do the agreement with the agency, is to allow designation of inspectors. Of course, it depends from one country to another. Some countries, you take the inspector, when you join as inspector, you take automatically the designation after they raise the name to the state. But in some countries, they don't allow everyone. It's a certain group, like for example, APAC, people who go to Argentina and Brazil. It's very specific and a certain number. They don't allow more than that number. Iran is the same, certain number, not more than that. So it depends from one state to another.
Yes, indeed.
Yeah.
So let me take a last question from Nidhi, and then we turn to the audience in the room. She's asking, how secure are nuclear facilities now with the implementation of modern seals and technologies? One moment, please. So actually, let me just say something to that. You know, we have the 3S, safety, security, safeguards. So safety is one aspect of using nuclear material. Safety is to keep us safe from the nuclear material. Security is to keep facilities safe from intrusion or from manipulation of nuclear material. And safeguards is to keep the world to the use of nuclear material in peaceful activities. So I don't know what else you want to. We are not looking at the security, but we are looking at the safeguards aspect. So I don't know what you can say on how secure are nuclear facilities with the implementation of modern seals and technologies.
Yeah, you're
Yeah.
right. It's more about the safeguard aspects, not about the security. But maybe this can be answered in a way. Maybe they talk about the data coming from the camera or from the surveillance. And this is what I mentioned.
Cybersecurity.
This is, that we have the authentication, we have the public key infrastructure, we have the digital signatures and all of that to secure the data
Yeah.
from the camera until it reaches the agency or used by inspector.
Okay, Nidhi, I hope this answered your question. Let me turn to the audience here, to the participants in the room, if you have any questions. Marwa, please.
Thank you so much for our organizer for giving us this great opportunity to upgrade our knowledge about novel equipment and safeguard. And my question, when you try to integrate this new technology in the field, do you have any challenges and how you can address this comparing with existing safeguard protocol and equipment right now? Thank you so much.
Yeah, thank you for the question. Of course, there are many challenges, and it depends on the instrument and the country. For example, in some countries, as I mentioned, they allow certain type of instruments. They don't allow other type of instruments, and it's always we reach a level where we need to talk to the operator or to the state authority. If they need more information, we can provide more information. In some cases, for example, with the European Commission, there is the EC, which is governing the safeguard in the Europe region, also involved in our negotiation and in our way of deployment and new instruments. For example, the new instruments, this one, the MCCM. The EC want to use it, and we have to provide all the information, graphics and the certificates. So they tested and then they authorized the use of this instrument in the countries belong to the EU. I hope I answered your question.
Thanks. Any other questions from anybody? Yes, please.
Thank you for your excellent presentation. I just had a question about something that you mentioned earlier, that SGTS is always looking for third-party or commercial solutions to problems you're solving with verification activities. Is it possible to estimate approximately how much of the development of equipment, physical equipment or software is coming from a third party versus how much is developed internally from SGTS?
Actually, it's very minimal. Like high purity germanium, yes, we found them because many people use high purity germanium, both electrical and nitrogen cooling. Sodium iodine also, but nonetheless, we want to replace this with our masterpiece, our new state-of-the-art technology. And for this, we had to work very closely with a vendor from the US. It's called HD3. And they had the basic technology, the gamma camera, and we gave them what we need. We told them we need this and that, and they developed based on our requirement, based on our cooperation. They developed what we need, customized for us. And this really brings a lot of challenge in our work, because who can be very interested to come and invest all that money, all that time, all that effort to support this limited pool of users? And this is why it's challenging, it's time consuming, but we rely a lot on member state support program. So for example, the robot, the XCVD, the robotic XCVD was really developed and tested with the support of the Australian member state support program. This one, the US member state support program, and we have different tasks that cover this development, and we bring even in the states sometimes not only give money, but also involve people in the national labs to work with us to develop this customized technology. Sometimes they allow us to have cost-free experts and GPO to come here and help us with this. And we have many examples of these people. And without them, I think it will not be possible. Thank you.
I think JPO stands for Junior Junior Professional
General
Officer.
And
So-
cost-free, yeah.
Yeah, and
exactly.
cost-free expert CFE.
Yeah, exactly.
Okay, thank you. Any further questions, either from the audience in the virtual session or physically present? If not, I'm looking at the time, so Janet, please go ahead.
Maybe a little bit provocative question. So, given all these challenges that we are facing now, do you think, as you mentioned often, we are ahead of the game? And what would you suggest, or what is it that we need to seek more in Department of Safeguards?
It is a challenging question. And I would.
You don't have to answer.
Thank you. Thank you for the option. But if it's my personal opinion, I think we're ahead of the game. I think the effort invested, all the cooperation we have, all the hard work we do, all the outreach we do, going everywhere, stay up to date with all the state-of-the-art technologies, with all the updates, I think we're still ahead of the game. A proof of that, we still can detect diversion. We still report some cases to the Board of Governors. So we still can verify whether the operator or the state are declaring the right thing with our verification systems. Thank you.
Personally, I think if the world wants to triple nuclear energy by 2050, and with many, many more facilities coming online, I hope this will go in hand with tripling the IAEA's budget, tripling IAEA safeguards inspectors and the staff in the Department of Safeguards. And of course, we all have to learn how to work even smarter than we are working now.
More efficient,
more efficiently
effective.
with new technologies, with AI support, etc., etc. Otherwise, this will not be doable.
Yeah. But till now, I think we still.
We
we
still haven't tripled.
We still. Yeah.
Still a few years.
Yeah, but
until
you're
2050.
completely right.
Yeah.
We need to look into what's happening in the world and stay
Ahead
really
of
on
the
top
game.
exactly.
And also new reactors coming online, which
Yes,
the
yes.
IAEA has never inspected before,
But
like
this is
pebble bed reactors,
yes.
molten salt reactors.
And this is why we have safeguard by design.
Yes, well,
And this is a new concept, safeguard by design. Any new nuclear technology that's coming now, we reach out to states, we tell them, okay, before you build, while you thinking of design, involve us, involve safeguard. We need to see what type of nuclear facility you're going to develop. We need to make sure that we will have access to install whatever we need to install, surveillance, use our instruments, have the infrastructure for unattended systems. This is very important. And now the constant planning section is working very closely, and they also working with us, with SGTS, with the people who develop the equipment, to make sure that we have what is needed and the states understand what they need to do to allow us from doing our safeguard measures. Thank you.
yes, safeguards by design is
Yes,
definitely a very
yes,
important
yeah.
concept. So I hope all developers of nuclear technology will go by it and introduce it. Okay, so I think this comes, we come to the end of our session. So thank you very much to our virtual participants.
But I still can't show it.
Oh, yes. So Ektimal is still going to switch to the close-by camera. So please go ahead.
Stop sharing. And This is this is the new instrument, which is replacing the HM5, and we see that this model is the same model as we use in different applications, but this is only a platform. This platform is based on a Raspberry Pi. So if we can run it here. And we can see the different applications for uranium measurements, enrichment. And this will be like an app on the new device where inspectors can use what type of measurements they want. They want spectrometry, they want active length, they want dosimeter, so they can use it. So it's like a mobile thing. And it's very handy, very fast, very efficient, and use the software that inspectors are using now in the field, the MCAT software.
The predecessor is the HM5, which I used in my time, and
Yeah.
this is
Still in use.
still in use. Okay.
This is another form of the same detector, but it can be used with different accessories. And here, we see that we have hole here where the rod, we say that this is a fresh a rod. It can be here, it can be measured like this, or we can put something here and we measure. So it can be used in different applications, or also on this with the magnet. It can attach to a UF6 cylinder and do the measurement. So with one piece of technology that the agency developed with the help of the US Member State Support Program, we managed to replace 4 types of instruments and use it in a different facilities. It can be used in a fresh fuel, in fuel fab, for rods, for pellets, and for UF6 cylinder enrichment facilities. Also, this is the camera. I did not show the camera before, but this is the camera. And it looks bulky, but if we open, it has a very nice feature. When it's open, if you see here, it says system locked since, and then the date. And I know that I'm the one who opened it before, so I can verify it was not opened after I opened it and closed it. And why this is important, why this is a new feature which helps inspectors in the field, because before this authentication is done, inspectors had, every time they open and close, they had to seal it. So they had here, we see this, here the holes. They had to put seals here, like this. They had to attach the seal here to make sure that nobody opened it. And can you imagine the number of seals produced from this simple action just to open? Now, this is why this is, have you used the XCAM?
Yes.
Okay.
It was already in use.
Yeah. And now, I will talk about the new seals. So this is just to show you, this is the old seal. The old seal, you have 2 pieces. You have to make the knot inside, and then inspectors can do nothing in the field. They only have the option to cut the seal, bring it to the headquarters, and in the headquarters, people verify whether it was tampered with or not. They have the image inside before and the image inside after, and that's the only way. However, for the new seal, this is the new seal, it is possible to verify in the field. It is similar to what we have in Cobra for the fiber optic, but now we have, this is the reader, and in the reader, here we have this fit into here, so we can have the image before and the image after. And from the image, so we use it either from this side, or from this side, or from this side. All of them, 3 images can be verified before and after in the field. And also all the images before this is sent to the field is taken in the headquarter. So in doubt, we can also verify in headquarter. That concludes my presentation. If you have any question, if you have anything, if you want later on for people around to come and see the equipment and use, very welcome. Thank you.
So a big thank you, Ektimal. This was really a wonderful presentation. I think all of us have learned a lot, even those who have not worked in safeguards yet. And even our technician. Thank you also for your support. So a big thank you and a big applause to Ektimal.
Thank you.
Thank you for your participation, also to our virtual participants, and also thank you for all the support by my 2 webmasters from Argentina, Agostina and Florencia, without whom this would not have happened. So thank you.
Thank you.
Thank you.